Okay, so this is the crystal violet experiment for chemistry 1420. And the first thing we're going to show you here is how to calibrate our spectrophotometer. And I know a lot of you have already kind of went through this before. We have the wavelength set at 590 nanometers, because that's where crystal violet does its maximum absorbance. Okay, and it's set on transmittance. There is nothing in the holder right now, so it should read no light going through because there's a shutter that comes down. So we're going to adjust this so that it reads 0% transmittance. If you want to, you can follow the instructions. They're in the lab manual in one of the appendices, how we're calibrating the spectrophotometer. Okay, so it has 0 with nothing in it. We are going to use water as our blank, so we filled the test tube with water, and I'm going to put the water in here. I'm going to line up the white part with the line on the spectrophotometer. Okay, and so with pure water in here, that's going to be where 100% of the light goes through. And so this needs to read 100, so I'm going to use the 100% T knob to adjust this to 100% transmittance. Okay, this is always a little bit touchy. Okay, 100% transmittance. Again, like I say, it's a little bit touchy to get it right on, but it's pretty close. 100% transmittance. Okay. The good thing is you have to adjust this every time you change the wavelength, but since we're using just one colored solution, we're not going to have to change the wavelengths at all. So once we get this calibrated, it'll work for the whole experiment. We may retest it in between each of our trial runs. But other than that, it should be good to go. Okay, the other thing we need to record is the room temperature. All right, for our first 2 trials, which will be at room temperature. So there's the temperature in the room. Okay, so you need to record that as well. All right, so we're ready to prepare our samples. We have our NaOH concentration that you'll need. Okay, so that's 0.01914 molar NaOH. I've already pipetted 10 milliliters into this smaller beaker of that solution. The other thing we're going to need is our crystal violet, and here's the concentration of the crystal violet. It's 3.03 times 10 to the minus 5th molar crystal violet. And as you can see, even though it's relatively dilute, it is very, very highly colored. All right, it's a very nice, I would suppose, violet colored. And we are going to pipette that. We're going to get 10 milliliters of it. And then it says we got to rinse the pipette relatively quickly because it stains, and we'll show you that it will stain your pipette. Okay. Okay, so you might be able to see against the white background how the glass has just a very, very light violet or blue tint to it. So we're going to have to rinse this out with deionized water so it doesn't stain, and then we'll use this every time we use the crystal violet. And then at the end of the lab, we're going to have to clean it with sodium hydroxide to get the blue color out. Okay, so we have our 2 beakers here of our crystal violet and our NaOH. what I'm going to do is I'm going to pour one into the other, and then I'm going to pour it back to mix them. Then I'm going to pour that into our test tube. I'm going to fill it, 2/3 full. I'm going to put then we're going to wipe it off, stick it into the spectrophotometer. Dr. Piento will start the stopwatch that you can see. Okay, that'll be time 0 is the first absorbance reading we get when he starts it. At times, that'll be your time 0 absorbance reading. Then I will remove the test tube, put it over here in the rack, and then when we get to roughly a minute, I'll take this out again, put it back in. When we record the absorbance, Dr. Piano will hit the lap time so you can record the time. We'll take it back out, set it back over here, and we'll do that every minute. Okay, so there'll be lots of readings. We have to go for what? 1 half-life, I think.
2 half-lives.
2 half-lives? Okay, we'll figure that out.
2 half-lives.
2 half-lives, okay? So whatever the initial absorbance value is, we'll take that times a half and then times a half again to figure out, we're going to keep going until we reach that absorbance values, because the absorbance will get less every time, okay? Because the crystal violet is decomposing, and so the absorbance will get less. All right, so it says to kind of have all this, have your chart ready in your notebook so you can record all this data. So we've kind of worked all this out beforehand. Luckily for you, you guys get to pause this and you can do that. We can't. So we're going to try this and hopefully not mess up. All right, so we're going to be ready to start here. I've got my 2 beakers, and we're going to mix them together, and we'll get going. Okay. And so our first absorbance reading is right there.
What was it, 0.9?
920.
9.2-ish.
Okay, so since the initial reading was 0.920, we're going to have to keep going until the absorbance gets to 1/4 that amount, which would be what, around 0.23. All right, so we're getting close to the value here, and we're ready to go. So when we do this, you'll hit the lap timer. When we get the thing settled down, here we go, 0.855. Okay. Yeah.
Good. Just wanted to verify.
Yeah. Just so we remember. Okay. Okay. Oop, didn't get it going. There we go. Now, the reason we don't just leave the test tube in the spectrophotometer the whole time is because it will warm the contents of your test tube. So we got to take it out every single time, so it stays at room temperature and doesn't heat up. Okay, there you go. Okay. Okay.
Can you see it getting lighter? It's hard to tell, I guess.
It is getting lighter, right? Especially if you compare it to the original.
Yep. Yep, you can see it.
Okay. Okay, so that was about 6 minutes, and we're at about 0.6, so we're getting there. This one's probably going to take the longest amount of time because it is the lowest concentration of OH minus, and it's
At
at
the lower
room
temperature.
temperature. Oh, sorry. Okay, there we go. Sorry, I was a little slow on that one.
It's all right when we graph it out, it'll be just fine.
It'll be just fine when we graph it, exactly. If you want, you could probably pipette some more.
Once every minute, no. I might cut it close to try to do that.
It's true. And so we're down to basically one half-life already. Pretty close.
Pretty close. So another 9 minutes, probably about 20 minutes total.
Yeah, probably about 20 minutes total. If it's first order.
Yes, that's a very good point. If it's not, then it's not going to be a linear line of time anyway.
Yeah.
And so. Okay. Getting close.
Yes, we are.
Okay. Okay.
And we made it.
Yes.
Okay, so now we've done with solution A at room temperature. Now we're going to do solution B at room temperature. So in this case, I pipette 10 milliliters of the NaOH that's now this concentration. So the more concentrated, it's 0.03828. And here's the 10 milliliters of the crystal violet that I've pipetted. Okay, so we've got our two beakers, again, the crystal violet, the NaOH. I'm going to mix them together, pour them into a test tube. We'll put it into the Spec 20. Dr. Pienta will start the timer when we get the first absorbance reading, and then we'll take readings every minute, just like we did before. All right, so here we're ready to go. Okay, there's the start. That's right. So it started at 0.935, so we got to go to 1/4 of that. Roughly 0.23 again. Now, in between runs, we did double check our calibration on the Spec 20 as well.
Okay.
Okay. Okay, now you saw on that one, it doesn't necessarily completely stabilize because it's going down at a pretty rapid rate. So we're just going to take a reading. You take a reading when we hit the lap time on the stopwatch, and that's what it'll be.
Okay. 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 Okay.
Okay, so that was your last reading because we went through 2 half-lives. Okay, so we now are done with the 2 runs at the low temperature, which was what we recorded earlier. So now we're going to do the same 2 experiments, the same 2 trials, but we're going to do it at a higher temperature. So again, we have the lower concentration NaOH, the 0.01914, and I put 10 mils in this beaker, and I put 10 milliliters, again pipetted in, of the crystal violet in this beaker. And so for this one, we're going to have to put them in a water bath to get them to the right temperature. So we're going to walk over here to the water bath, and we are going to put them in the water bath, and Dr. Pienta is going to get a close-up of the temperature, the water bath, and then I'm going to go ahead and we're going to put these into the water bath here. They're setting to get to the right temperature. Okay? So they have to be in there for about 5 minutes. And so we'll tune back in after 5 minutes. Okay, so we are about ready to start the high temperature runs with the lower concentration of NaOH. Okay, so the beakers are still in the water bath. I'm just going to explain kind of how this goes because this is a little more tricky. I'm going to bring them out here. I'll show you the 2 beakers. I'll mix them. I'll pour them into a test tube. Then I have to dry the test tube with a towel, wipe it with a Kim wipe, stick it in, get the absorbance reading. We'll start the timer. Then I have to put it back in the water bath because we want to keep it in the water bath as much as possible to keep the temperature the same. And then every time that we need to take an absorbance reading, I have to pull that out, dry it off, wipe it off to put it in there. So it's a little more of a procedure that we have to go through here. So I wanted to run through that before we start. All right, so we're getting ready to go. Dr. Piano, you ready?
I'm ready.
Okay.
So if you just dry them off in the bottom real quick.
Okay, so here's the two beakers. I'm gonna mix them. I'm gonna fill our test tube. I'm gonna dry this off. I'm gonna wipe it off. I'm gonna take the reading. So. Okay, here's the
Okay.
first reading. This up a little bit, yeah. We'll do it after the next one. So now one of the key things for this is you got when you're in the water bath that the level in the test tube of the liquid is not above the level of the water bath, so I'm going to have to dump a little bit out of my test tube. So we're ready to go for the second reading here. Dry it off, wipe it off.
Okay. It was about the same for 93.
another minute or two, and hopefully we'll be done with this one. And remember, every time I'm wiping it dry to make sure that the water on the outside is not affecting our readings. So I'm wiping it dry and then wiping it with the Kim wipe every single time.
Okay.
Okay, that's good enough. Okay, so we have already got our second run at the high temperature. We pipetted the higher concentration of the NaOH, the 0.03828 molar, and we pipetted the 10 milliliters of crystal violet. We put it into small beakers. We put it into the hot water bath for 5 minutes. So we're about ready to get going, except I need another test tube. Okay, so we're going to use this test tube. Put that into the test tube rack that's in the water bath. So I'm going to come over here. I'm going to mix the things quick. Again, pour it into the test tube, dry it. We'll start the timer, and we'll again keep the test tube into the hot water bath as much as possible. All right. Okay, so here's the 2 beakers. Mix, and mix. Fill up our test tube here. Dry. Into the Kim wipe. And we need to start the timer. This absorbance reading. Okay, there it is.
That one was a little lower, so 1/4, it's 0.22.
Okay, 0.22. Okay, so we got to go a little bit lower on the absorbance. But this one should go pretty fast. In between runs, again, we double check the calibration on the Spec 20, so we should be okay with that. One thing to note when you're recording these, right, if you're recording what the stopwatch says, you can round up to the nearest second. You don't have to record the hundredths of the second. And then you're going to want to turn all of these from minutes, seconds, into probably all either all minutes or all seconds. So you'll have to do a conversion on those, because when we plot them, you're going to want to plot them in 1 unit, not a minute seconds.
Okay. Okay. Okay.
So probably 1 more minute.
Okay.
That's it.